Hey guys, I thought we would talk for a minute about powers and roots today. So let's start with, for a real number a and a natural number n, we have a raised to the n, which is a is used as a factor n times. So we've written it here like a times a, well, times a times a times a times a, n amount of times, right? So we say that we are raising a to the nth power. A is the base, and n is the exponent, right? You can see that here. This is our base, and then n is our exponent. Okay. It is very important to note that what the base is in an exponential expression. Okay, so let's see if we have like x squared. This little 2 up here tells us that we're going to have 2 x's, right? What if we have a cubed? What does that tell us? Well, that tells us that we're going to have 3 a's, right? But the exponential expression is this, right? It's a base raised to a power. That is the exponential expression. So when you have one like this, you need to pay close attention to what your base is. So like, let's look at these. Our base for this one is our 5, right? So that tells us it's 5 squared. So we're going to have 5 times 5, which gives us a positive 25. But if your base is in parentheses and it's negative, then our base is the negative 5. So we have negative 5 times negative 5, which gives us a positive 25 again, right? Because we multiplied a negative times a negative, which gives us a positive. On this third one, though, the 2 is only attached just to the 5, right? The negative is on its own. It's like negative 1 times 5. So we have a negative 1, and then our 5 is what was squared. So this answer is negative 25. So it really, really matters what you're squaring. So you got to be paying close attention. Here we have 2, right? That's our base, and it's cubed, so we know we're going to have 3 2's, which is 8. Again, our base this time is in parentheses, so we know that the 3 goes to both, right? The exponent goes to the negative 1 and the 2. So negative 2 times negative 2 times negative 2, well, that gives us negative 8. And then here we have negative, which is not included, and just our base is 2. So it's negative 1 times 2 times 2 times 2, which gives us negative 8. Okay. Anything to the 0 power is always 1. This is a rule. I wrote it here. It's in the next set of rules, but I just thought I would throw it up here as well. It really helps to memorize that, so I would really suggest you to remember this. That's not how you spell remember. Okay, it'll come in handy. Alright, so let's look at some exponent rules, okay? Or properties of exponents. So these are like the rules that we have to play by. For non-zero real numbers, a and b and m and n have to be integers, okay, for this game to work. So our first one is if a equals, or any, like a equals a to the first power. So a is any real number. So if a power is not written, the exponent is 1. So I'm sure I've said this before. If I haven't, I've missed great opportunities, I'm sure. Mathematicians as a whole are lazy people. So any whole number, like let's say 5, can be written as 5 to the first power, right? But we don't want to take the time to write to the first power every time we write a whole number, so we just don't. But just know that that's always implied, right? So if we have 7, that also could be written 7 to the first power, okay? So any whole number or a variable. Let's do that. That's fun. What if we have x? How can we write x? If you said x to the first power, you are correct. Okay? Let's go on to the next one. The next one is anything, like a to the 0 equals 1, right? And I said anything. There is one exception. You know, it's math. Very seldom does anything work. So anything except for 0 raised to the 0, which is undefined, okay? So anything except 0 raised to the 0 power is 1. So what if we had, I don't know, like 10 to the 0 power? What's that equal? 1. 2027 raised to the 0 power. What does that equal? 1. You get the idea? X raised to the 0 power. What does that equal? 1. Okay. Anything except for 0 raised to the 0 power is 1. Alright, now let's look at this one. We have A, our base is A, raised to the n power. And then we multiply that by the same base raised to a different power, okay? If we have same bases raised to different powers, we could rewrite that with just one time. Just write the base once and then add your exponents. So when you multiply powers of the same base, you add the exponents, okay? Let's make it color. So let's say we have x squared times x to the 5th power. So we could take this and rewrite it as x2 plus 5, which is x to the 7th power, right? Pretty cool. Let's do, how about this? 2 squared times 2 cubed. Well, we would write it, our base is 2, and then we could add these, so it would be 2 plus 3, which equals 2 to the 5th power. Oh, my computer over here went to sleep. Give me a sec. There we go. So 2, let's see, everything went to sleep. 2 raised to the 5th power is 32. So that equals 32. Okay? That's how you do that one. Now this was, if it was multiplication, you add. So what do you think you would do if it was division, right? If you have the same base and it's division, different exponents, well, then you're going to write it as one base, and you're going to take the top one and subtract the bottom one. So it would be m minus n, okay? So when you divide powers of the same base, you subtract the exponents in the following way. The numerator exponent minus the denominator exponent. So if we have, I don't know, x to the 7th power over x squared. Okay, so we're going to write our base once, and then it would be 7 minus 2, which is going to give us x to the 5th. Okay. What about here? If we have one base, this is the difference between the multiplication before. If we have one base this time, but it's raised to two different powers, right? We have m raised to the n. When this happens, I need a different color, let's do pink. When this happens, we multiply the powers. Okay, so we write our base over just by itself, and then we multiply m times n. So when you raise a base to multiple powers, you multiply the powers. So if I have x cubed, and then I square that guy, right? I just rewrite my base, and then I say 3 times 2, which gives me x to the 6th power. Right on. This is going to be a long video, sorry yo. Okay, so now we're going to talk about roots. So finding the root is the opposite of raising a number to its power, okay? So a second root, or the square root, that's what we call it usually, not second root, but we'll call it square root, is written with a number under a root sign. This is the symbol, and this is called a radical sign. All right. More generally, we indicate the nth root by writing the number under, and then like we just put this little n up here, right here, just to show that's a placeholder for whatever root that we're going to take, okay? So let's look at these real quick. So if we are taking the square root of 4, that's asking what number is there 2 of? Like, it times itself to give us 4. Well, we know that's 2, right? Because 2 squared, 2 times 2 is 4, right? So now we're going to say, what is the cubed root of 27? So we want to know what number exists that multiplies by itself 3 times to give us 27. Well, that's 3 times 3 times 3, right? Because 3 times 3 is 9. Times 3 again is 27. So 3 cubed. So the answer is, 3. Okay, now we're taking the 4th root of 16. So it wants to know what number exists if you multiply it by itself 4 times would give us 16. Well, that's 2 times 2 times 2 times 2. Because 2 to the 4th power is 16. So our answer is 2. Now, this one looks like it's really hard, right? We want to know what number multiplied by itself gives us 1 million. Well, if you count the zeros, like here's 1 0, 2 0, 3, 4, 5, 6, it tells you that that is 10 to the 6th power. It's a really cool trick that you could do as long as it's a number that just includes ones and zeros. You know it's divisible by 10, and then if you count the zeros, that gives you your power. It's a pretty neat trick, huh? It's very useful in the math world. Alright, so let's talk about roots of fractional powers. So the nth root of a number is the same as the number raised to the 1 over n power, okay? So here is our little fact. If you have x raised to the 1 over n power, that's the same thing as taking the nth root of x. And I'm going to show you why. Okay. So remember I said we're lazy mathematicians. So x always has this little 1 power right here, right? So you see that 1 power is right here. This is the root. So when you rewrite it, the root goes on bottom. So that's how you get 1 over n, right? Because you take him and you put him underneath here. And then that gets rid of the radical sign. Get rid of that. How you remember that the n goes on bottom. You just remember it the hard way and do it over and over and over till you remember it. This is how I remembered it in college algebra, and if it's silly to you, then forget it. If it helps you, then that's my mission, okay? So we have trees, right, in the real world. I'm going to draw my tree black because I don't have a brown. So this is my tree with green top, hopefully. So the roots on a tree are on the bottom, right? So these are my roots. So the roots are on the bottom, just like the root is on the bottom here. So this is our root. That's how I remembered it, like in a real world situation. And then here's going to be my power pole. If we have a power pole, like the power lines run up here on the top, right? So these are my power in the real world. And our power goes on top. So that's how I remembered it in the real world scenario. That helped me in my math scenario. So whenever I turned, like, I don't know, I don't usually write a 2 there, but the square root of x into, from radical to rational, I would say x, you know that there's a implied 1 here, and then that was my power. My root always went on the bottom. So that's how I could turn it from one to the other, okay? Like just thinking about tree roots are on bottom, power's on top. Maybe that'll help you, okay? If not, then that's the most expensive picture you've ever paid for, like, because this class's tuition was a lot. I'm just joking. It's not that much. Okay. So here's one that is done over. So like you have 64 raised to the 1/3. We know we take this is the root, so it's going to go here. We put the 64 underneath the radical sign, right? By the way, what is underneath the radical is called a radicand. Cool? It's pretty neat, I think. So anyway, then when you ask yourself, what multiplies by itself 3 times to give you 64? That's 4. And then again here, we've already done this one up here, so I'm not going to talk about it again. Okay, and I think we're done. That is it. I hope you guys have the best day.